Hi, this is Involved Innovation YouTube channel. In this video, we will see about solid design principles. Solid design principles are a set of best practices originally popularized and named by Robert C. Martin. Here, if you are developing an enterprise-grade application, following the solid principles is a really must. And if you are aiming to become an intermediate level engineer or senior software engineer, you need to be knowing these design patterns. In the solid design principle, each character stands for a particular principle. That is, S stands for single responsibility principle, O stands for open-closed principle, L stands for Liskov Substitution principle, I stands for interface-segregation principle, and then D stands for Dependency Inversion principle. Now we will see why we really need to adopt the solid design principle. If you are using the solid design principles to develop an application, on a longer run, this application is easy to maintain because you are utilizing the best practices which are a result of years of work. And then next, increased code reusability. This is purely because your code will become more modular, that increases code reusability. Next important thing is you can increase the unit test coverage. So if you want to create an application with very less bugs, you need to have a good test coverage. The test coverage also facilitates us that if you are creating a new functionality or if you are adding a new functionality to your existing application, this existing test coverage gives us a guard to understand whether there is any problem which you have added with your new code. Flexibility to add a new functionality. If you are developing an enterprise grade application, no application is gonna stay like it is. Seeing a YouTube code base, on the very beginning the code base might be very small. On a longer run, on day-to-day basis, there are developers who are working on it to increase the functionality and improve the performance and different things. So for that, they will be keep on adding the functionality. So if you are need to keep on add the functionality, then you need to have a good design principles behind it. So this solid principle provides all these key benefits. With that, we will start with the single responsibility principle. The single responsibility principle is very straightforward. That is, a class must be responsible for only one thing. If you are creating a class, you must be very mindful that you are utilizing this class for a single functionality. If you want to use single responsibility principle, you need to use a small class with a specific purpose. If you are creating a class, you should be covering a specific functionality for that particular class. That class should not have more than one functionality. We will see more about this when we are seeing a coding example with the employee management system. Avoid large class with generic purpose. You should not create a bigger class and it serves more than one specific purpose. On the reverse side, extreme implementation of single responsibility principle is also bad. For example, like creating a class with only one function and making it really small, that doesn't help either. For this, I will use a particular analogy. I am taking two different images here, like juggles like n number of balls, and it is really difficult. If you want to add the balls here, a person can't juggle more than n number of balls. If I want to change a small thing here and there, that becomes more and more difficult to manage. Because single class handles multiple things. Now think the same analogy with a single class. You can do much more thing. You can do acrobatics and you can play with it if a class handles only one thing. So this is a very simple analogy. So it is always easy if you are using single class for a specific purpose rather than using a bigger class with different functionalities. So for this, I am using a employee management system as I mentioned. So here, this is the repository I am using. For each pattern or each principle, I have created a particular commit hash, so you can go and refer that particular commit. Here in this application, I have employee service. So here, if you see this employee service, and then I also have employee address as a bean and employee detail as a bean. So here in this case, employee service has different functionalities such as get leave balance, and then apply leave, and get referral link, and then change contact info, and then generate pay stub. This name sounds very generic. Here I have placed different functions. The leave balance function, which can be put in a different class altogether because it serves timesheet functionality. Similarly, like apply leave, get referral link function might be related to the employee referrals, and then change contact info might be belong to the employee service, and here generate pay stub might be related to the employee payroll service. This is clearly violating single responsibility principle purely because the employee service is not for a specific purpose, it serves different purposes. So for example, now in your application tomorrow there is a simple rule change for a referral link, like you have a referral link and you have a bonus for each referral link, and you have a code here, and then you need to make sure you are changing this in this file. Then this file will become more and more big and it become a maintenance nightmare. And also with the file name you can't really predict what this file does if it is more generic, so that there is a possibility that you might be missing some places where the change need to be there, and vice versa is also possible. You might be doing something somewhere which is not really required. So to adapt the single responsibility principle, I will go ahead and change by creating new services. First, I will create employee timesheet service. This timesheet service can hold the get leave balance and apply leave function. So I will create a new class and I will name this as employee timesheet service. And here I can remove this get leave balance and apply leave, and I can move this directly to this particular class. So now we will go back to the employee service. We can able to still see the referral link. For that, I will create a new class named employee referral service. And in this class, I will copy and paste the get referral link function. So copy this get referral link, paste it here. So here the payroll service can hold the generate pay stub. I will cut this generate pay stub and I will create a new service named employee payroll service. Now this generate file is still in the employee service. So here the generate file not fit in the payroll service. This because this is a particular utility. So for that I will create a brand new module or brand new package and I will place it there. So I will create a new package named utility.file generator, and here I will copy and paste the generate file. Now we have created this employee payroll services. Now we need to add the dependency. Now the generate file is not within this particular file. So what we can do is we can add this as a dependencies in this particular payroll service. We can create a bean for this. To create a bean in Spring, you can annotate this particular class with component. Then you can go to the employee payroll service and then you can create private final file generator, and here we will mark this as a component, and then to inject the file generator bean, you can create a constructor. For this I am using Lombok required args constructor that will automatically create a constructor for us, and that constructor will take file generator as a bean. So now we have the file generator. Now we can pick up the generate file function from the file generator. So now this is good, but still it is violating the single responsibility principle. This is because here we have a database call. Here I have added a particular command, but still this database call is directly used here. That is really violating the single responsibility principle, because we don't have any repository package, because this all need to be handled in a different class and all the CRUD operations need to be handled separately, because this class has nothing to do with the CRUD functionalities. So to do that, I will create a new package and I will name this as repository. Think that we have a table named employee referral. So we will be creating a repository for each and every individual table. So here I am creating a new repository for the employee referral table. Now I have created an employee referral repository. So I will make a bean of this. So component. In the employee referral, I will create a new function which takes employee ID and registers that employee ID, and it returns the corresponding referral URI link. Now we will go to the employee referral service. Here I will make this as a component required args constructor, and I will add the employee referral repository and the employee referral repository dot register employee referral, and here employee ID. Now we have removed the database call here, and here instead of doing the database call directly in this particular class, we are using employee referral repository. Here this class is responsible for all the operations which we are doing with the employee referral table. Now I will also create another repository named employee repository that will hold the link between employee table and then this application. And in the employee repository, I will create functions such as get leave balance. So the get leave balance functions takes the employee ID and returns the leave balance by contacting the employee table, and the update employee leave contacts the employee table and updates the leave information there. Update employee address updates the employee detail. Now we can go to the employee service. Here in the employee service, we have change contact info. So for change contact info, we can use employee repository. And then here, instead of making the database call directly, you can do this like employee repository dot update employee address and then employee detail. And this is the same for the timesheet service. So I will copy this employee repository and I will paste it in the employee timesheet service. So here we are making the database call directly. So if you are making the database call directly, then that is violation of single responsibility principle. So we will modify it to get the balance. Now we have modified this logic, and here we also need to validate whether the employee really have a leave. So now we have segregated this to a different function. We can quickly use this particular function which we have given here. So before you have seen we have only one class, that is employee service, which does everything. It does the database call, it does the payroll thing, it does the referral services, it does timesheet services, and it also facilitates us in generating the files, that PDF file or CSV file, whatever it is, the pay stub generation also there, this employee service. On a longer run, this is easy to maintain and you can make this application more modular. So this is single responsibility principle. Now we will see what is the advantage of using simple responsibility principle. It reduces the tight coupling purely because like we have a single class handling particular functionality that reduces the tight coupling, and then it is easier to perform unit testing because here the scope of each class is very limited so that you can have a better coverage. This is single responsibility principle. We will now see about what is open-closed principle. The open-closed principle is often very confusing principle, but I will make this very easy for you guys. So now the open-closed principle states that classes should be open for extension but closed for modification. What this means is like if you are creating a new functionality, that functionality should add a new class rather than altering the existing class. For example, if you are creating a car class and if you have a steering class, in the steering class, if you have added a brand new functionality, there you should not altering the original class, rather than you need to be having a interface. That interface provides us a way to extend the functionality rather than directly changing in the class. We will see this with the example in the employee management service. To avoid this, and using switch condition or if else condition by adding a new logic directly in the existing class. So what we are really going to achieve with this open close principle is like, I want to give this with analogy. Let's take, we have a piping system here. This system is not following the open close principle and this system is open for modification. Now let's take, this is an existing application which is running good for like years and years. Now this application, you are allowing it to modify. If you want to add a new functionality, if you want to add a new piping service, or if you want to add a new outlet, you are going to change the existing thing. So for example, here I am adding a new pipeline to the existing system or directly modifying it. If there is something worse going on, if you have added a new vulnerability or if you have added a new bug and that makes the existing system also break, a new functionality is also not going to work. So this is a very worst situation because you have introduced a new bug and this makes the existing functionality to not work correctly. This is a maintenance nightmare. So this open close principle really provides a way. So if you want to add a new functionality, the existing thing is closed for modification. You can't really modify the existing system, rather than it can be extended. For example, here there is 2 outlets and the internal system is closed for modification, so that we are extending this and we are adding one more outlet. So here we have 3 outlets in the open for modification and also in the closed for modification. We didn't change anything directly there. Even if there is some issue with the newly introduced code, then also we don't really have an issue with our existing system. We can easily find what is really going wrong with our system because we haven't touched the existing system. So we will see this with our employee management system. For this, I will go into the file generator function. Now here you can able to see I can generate the file as PDF or XLS. Now let's take tomorrow there is a new requirement that I also need to generate this file in doc format. So I will create new if else logic, and here instead of XLS I'm just giving it as doc. If it is doc, then I am adding new condition here. So if the file type matches this doc, then I am creating a brand new logic which creates byte array output stream, and that will have the doc file. So what is the problem with this? If we have messed up with this, then there is a heavy possibility that PDF might be also not working. XLS might be also not working. So in your case, the PDF generation might be the core functionality of your application. To remediate this, what we are going to use is the open-closed principle. To use the open-closed principle, first we need to start with creating an interface. So that abstracts or gives us a solid template what all the different things you need to follow when you are creating a new functionality, and also this makes sure that you are not touching the existing functionality. So I will make this file generator as an interface rather than class. Rather than having this particular function, I will make this as an abstract function. So here, whenever you are going to create a new file generator, that must have a generate file. So now here I will create a new class, that is the PDF generator. Now this PDF generator class implements the file generator, and here instead of this, for now we will return byte array output stream. Now this PDF generator class is only for PDF generator. As long as there is no change in the PDF generation logic, we are not going to touch this PDF generator. If you want to add a new generator like CSV or doc, you will be creating a new class like CSV generator, and it implements the file generator as well. And here we need to write a concrete generate file function, and here we will return new byte array output stream. Now we have extended this functionalities, like you can utilize this file generator, and this file generator acts as an abstraction or gives us a baseline to create different generators. As long as there is no change in that particular generator, we won't be touching it for creating a new file type. If you are using open-closed principle, you also need to create a factory class, because that factory class will handle the bean creation logic. So I will be creating a new package, that is factory, and I will name this as file generator factory. So this file generator factory gets a file type, and if the file type is matches to PDF, it provides that particular bean. If the file type matches CSV, it provides that particular bean. This return type is file generator. So if you are using the return type as file generator, that means this can be giving any subtype of file generator. So here CSV generator is also subtype of file generator, or PDF generator is also subtype of file generator. So if you are creating doc generator, that is also going to be a subtype of file generator, as long as that particular generator implements the file generator interface. And now go back to the employee payroll service. Here remove the file generator, and instead of file generator, now this file generator factory has a static function which is a file generator, file generator factory dot file generator, and now this will provide us file generator type, file generator dot generate file, and now this file type is no longer needed here. So here we can pass the employee data. So employee detail, and here employee detail. Instead of file type, you can pass the employee detail, save this. This is violating the single responsibility principle because here we are directly making the database call. To resolve that, I will create a new repository and I will make this as employee payroll repository, and inside that I will create a new function and go back to the employee payroll service. Here add this as a dependency, private final employee payroll repository. The employee detail we can get from employee detail equal to employee payroll repository dot get payroll employee ID. So now we can remove this off and we can remove this comment. We have created file generator factory. So the file generator factory creates the bean based on the file type. If the file type is PDF, it creates a PDF generator bean, and we can use that particular bean to generate file. So this is open-closed principle. The open-closed principle facilitates us that we are not altering the existing logic. So if you have seen the old code, we have used the if-else logic. We only had one class, that is file generator. So if a new request comes in to add a new type, we will be modifying directly there in the file generator. But now with the open-closed, we made that file generator as a interface, and we have defined the template, and from there we have created classes for individual generators like PDF, CSV and doc. Now with this we will see the benefits. The bigger benefit is flexible to add a new functionality without impacting the existing code. If you are utilizing this open-closed principle, that facilitates us to add new functionality seamlessly, and it also guarantees you that existing functionality will work as before. Since it is very modular, we can perform unit testing better, and here we can also create unit testing without altering the existing code. For example, if I have a unit testing logic for PDF, I am not touching it. If we have everything in a single place, if I am not using open-closed principle, if I am modifying that, then I need to modify my unit testing also to fit in that particular logic. Now with this, we will go to the next principle, that is Liskov substitution principle. The Liskov substitution principle is originally given by Barbara Liskov in 1987. A few years later, she published a paper with Genitin Wing, in which she defined the principle as let phi x be a property provable about objects x of type T, then phi y should be true for objects y of type S, where S is subtype of T. This is really difficult to understand, so we have broken this. This can be reframed as, if S is a subtype of T, then objects of type T might be replaced with the object of type S. That is, an object of type T may be substituted with any object of a subtype S without altering any of the desirable properties of the program. Now this is still confusing. Now we will see the same definition with a small diagram. So here I have a parent class team and I have a subclass S. So now this T is an interface. Think this as an abstract class or interface based on which I am creating a new class, and that class is S. And I can create objects out of S. In somewhere in my code, I am utilizing this S here. So now, for example, in somewhere I am taking this S class and I am calling some functions in the S class. In addition to S, there is other classes like P and Q, which also subtype of T. With this, what Liskov principle states is, if X takes S as one of the parameter and utilizes some of the functions as of S, then if I replace the S with P or Q, then the program should work the same way before. This is what the Liskov principle states. What we need to use and what we need to avoid. Only the closely related types must be grouped under one set. So to avoid this, even if there is a small functional difference between two different things, it should not be joined under the same thing. You will see this with the analogy. Let's take, we have a bird interface. That bird interface has different birds. Here in this case, we have a vulture, we have turkey, we have pigeon, and then we have hen. And for this purpose, I am using an incubator class. That incubator class takes any of the bird and it utilizes get egg function, and then it uses that egg for the incubation. Let's take, this is what this incubator does. If you are utilizing the vulture class, then if I modify that to take the turkey class or pigeon class or hen class, then in that case the code should work, the incubator should work without having any issues. This is what the Liskov substitution principle states, and we will see this with our employee management system example. To demonstrate this, I will create a new package and I will create a new interface named employee expense. So I will put this in expense package and I will create a new interface named employee expense. And here I will add two functions. One is public long monthly salary, which takes month and year as a parameter and then gives us the monthly salary. Another one is get performance pay. For this also we will take month and year as parameters. I will create a class developer expense implementing this employee expense. Here we need to implement the methods. Okay, here I will add 10,000 and here I will add 500. Now I will create another class which is manager expense, and this also implements the employee expense 15,000. Now we will create a consolidation class. Now create a new package and I will make that package as department consolidation. Now we have created the employee consolidation class. Here in the employee consolidation, I am taking the employee expense and here I am adding all the employees. I have created a new function. This function takes all the different types of employee expense and it adds to the employee expense list. And then here we are using the monthly salary function to calculate the total salary. Now we will create a new test class to test this functionality. Here I will create a new test class department consolidation test. Now what we have done here is we have created developer expense and then a manager expense, and both is of type employee expense. We are not really worried about what is this developer expense or manager expense is all about. As long as this is of type employee expense, this function add employees should take it. Now we have passed in this developer expense and manager expense inside the developer consolidation because this need to be of type employee expense. Now if you run this add salary test, we got the correct result. This is because this developer expense and then the manager expense both are of type employee expense, and it correctly uses the two functions, which is get total salary and get total compensation. Both are utilized there. The employee expense dot monthly salary is used here and the employee expense dot get performance pay is used here. So this is what the Liskov substitution principle states. So in the Liskov substitution principle, if I have a type S which is of subtype T, here T is employee expense and S is developer expense. If I am using the developer expense here and if I create a new subtype of employee expense named manager expense, if I use that in this particular department consolidation, it should work fine. Now I will create a small code which violates the Liskov principle. For this I will create a new Java class and I will make this as intern expense. So this is to get the intern expense, and here in the intern expense I will create the same two functions, but the interns only get salary but they won't get the performance pay because they are not the regular employees. Implements employee expense. So here when we try to call get performance pay, we are throwing a runtime exception stating interns are temporary employee, they don't have appraisal, but we are providing the monthly salary. But let's take this department consolidation doesn't have any idea what the implementation logic. Here we only worry about whether this takes employee expense type. So I will create a new employee expense of intern. So this is intern expense and here this is new intern expense, and I will pass this to add employees. Now if I run the same code again, the get total salary is working fine, there is no problem whatsoever. But here when we try to get the compensation, we are getting the runtime exception. The runtime exceptions is interns are temporary employee they don't have appraisal. This is violating the Liskov substitution principle. This is purely because this particular class, department consolidation, doesn't have any idea about how we are implementing it. The solution is, in this case, you should not group this intern expense under employee expense. You need to be creating a separate interface which includes this intern expense. So this violates the Liskov principle because the intern expense is not a true employee expense. This is not a true employee expense type because we can't really implement the get compensation method. So this is Liskov substitution principle. So now we will see the advantages of using Liskov principle. It improves code reusability since any subtype of parent can be used interchangeably. So here we can use any subtype. Here in this case we have used manager expense and employee expense interchangeably, and this is also a better software design, and then provides guidelines for the new functionality to be created because you already have a template to follow and you can clearly see, okay, if this is of the type, then you need to be implementing that particular interface. If not, we should not use that interface. We should be creating a different interface altogether. So this is Liskov substitution principle. Next we will see about interface separation principle. The interface separation principle is fairly easy in the solid design principle. So the interface separation principle states that no client should be forced to depend on the method it does not use. So with the same intern example, I will go and explain here. So here the intern expense should not have the performance pay. With the intern expense logic, we will see we have employee expense interface. It has monthly salary and get performance pay. In the intern expense, since we are implementing this employee expense, we have written get performance pay. Here in this get performance is not needed. So here we are throwing a new runtime exception stating interns are temporary employee, they don't have any appraisal. So here we are forced to use this particular function purely because we are implementing the employee expense. So if this is the case, we should be breaking this employee expense to further division. That is, like, rather than having two different functions, we should have only one function and another function with a different interface. So this is what interface separation principle states. The interface separation principle states that no client should be forced to depend on the methods it does not use. So here in this case, we have seen intern expense are forced to use the compensation function because it is implementing the employee expense interface, which has these two abstract functions. So the use is group only functions which are closely related interfaces and make the interfaces small. Avoid is obviously the bigger interfaces. You should not have a bigger interfaces. If you have a bigger interface, most probably this is against the interface segregation principle. So now we'll see this with the analogy. Now we have a bird class. The birds are not all should be in a single interface. For example, if you want to use the fly function, then it is gonna break all the flightless bird. So you should be creating two different interfaces, where in this case you need to separate the flying birds and the flightless birds. If you are creating interfaces, you need to make sure you are creating interfaces which are closely related. We will see this example with our employee management system. Now we already saw this employee expense is not the correct way. I will create a new interface which is full-time employee expense, and I will move this employee expense get performance pay to the full-time employee expense, and then go to the intern expense. Here this should not be overriding the get performance pay because this is no longer needed because the employee expense only has the salary. The full-time employee expense has the compensation. So if you go to the manager expense, here instead of implementing only the employee expense, you should be using the full-time employee expense as well. So the same for the developer expense. So go back here and then modify. Here it should also use the employee full-time expense. Now I will create an interface named expense consolidation, and this expense consolidation has get total function, and then here I will go back and change this department consolidation. I will change this to department salary consolidation, and here it takes employee list in the constructor and then employee list equivalent to employee list. So this dot employee list equivalent to employee list, and then remove the add employees. We no longer require the add employees here, and here the get performance pay is not in the employee expense. That is why it is erroring out. Now remove this as well. Now rename this file. I need to make sure I'm implementing expense consolidation. So implements expense consolidation, and this is not get total salary, this is just get total. I will create a new class, department compensation consolidation, and here this implements expense consolidation. This is get total at override. Go to salary consolidation and copy this, and here instead of employee expense, this is full-time employee expense, and this is employee compensation consolidation, and here instead of employee expense, this is full-time employee expense. Now this is perfect. Now what we have done is we have used the interface segregation principle, and the interface segregation principle states that no client should force to depend on a method which it doesn't use. So in this case, before we had employee expense, the employee expense also had the compensation, but now what we have did is we have created two different interfaces, one for employee expense which only has salary, and then a full-time employee expense which has get performance pay. So this develop expense implements both employee expense and then full-time employee expense. Same for manager expense. This implements employee expense and full-time employee expense, but the intern expense only implements the employee expense. So we no need to even create that function. Before we have created that function and then we have thrown the runtime exception, we are forced to create that function because we were implementing the employee expense which also had that get compensation pay. We have created a expense consolidation interface. We have created two different. You might have noticed now this is open-closed principle. I will modify this. No, this is fine. Now run this again. Now we can able to see the total salary and then total compensation. This also adheres to the Liskov substitution principle. Now if you have employee expense usage class, no need to understand what is the implementation. As long as this is of type employee expense, it must be readily available to use here. And here we can able to add the developer expense, manager expense and intern expense. In this case, we have full-time employee. The intern is not full-time employee. The developer and manager are full-time employees. So we have added the developer and manager here, and we can able to see the result. Now we will see the advantages or the benefit of using interface segregation principle. Here the reduced coupling because of smaller interface. It also increases the modularity so that you have a smaller interfaces, so you have more modular code. This is very easy to create unit testers because you are making the file size small so that you can add more coverage. Now this is interface segregation principle. Now we will see about dependency inversion principle. Dependency inversion principle on a very high level. High level modules should not depend on low level modules. Both should depend on abstractions. Abstraction should not depend on details. Details should depend on abstraction. For the first part, we will see this with analogy. So abstraction should not depend on details. That is like interfaces should not be depend on the classes which it is implementing on. For example, here in this case, we have created employee expense. Employee expense is an interface which is not depend on the manager expense or developer expense, but in turn, the details is employee expense or manager expense, but that is depends on the employee expense interface. So that's why the abstractions here is like abstract class or interfaces that should not be dependent on the implementing class, but the implementing class must be dependent on the interfaces or abstraction. Now we'll see this first line definition. High level module should not depend on low level modules. Both should depend on abstraction. First, Here we have created a high level module. Let's take, we have created a class, we have defined everything, but for this tire, instead of using abstraction, we have utilized the direct tire class itself. So now what happens here is, like, if we want to change this to a different tire, then we need to change the code there. Then you need to change the high level modules. What a dependency inversion principle states, that is, if you are creating a high level module, it should not depend on the details, rather than it should be depend on the abstractions. So here the tire is more like abstraction. You can pass in any tire type or tire class. If you are creating a high level modules, it must be depend on abstraction rather than the real class itself. To avoid is like class which depends on the details or the implementing class rather than abstract class or interface. Now we will see this with our code. We already adhered to this principle in the department consolidation. If you go back and check the department salary consolidation, here we have utilized the employee expense. Here the employee expense is not implementation, rather this is abstraction. For example, here if I changed, instead of employee expense, if I directly giving it as manager expense, then class is no longer gonna work for developer expense. This class will only work for manager expense. That means, like, you can only add the type manager expense. So now if I change this to manager expense here also, now if we go back and check this test class, you can see there is an error. We can't really add the employee expense list because the employee expense list is using the employee expense. Now if we change this manager expense, now we no longer can able to add the developer expense and intern expense. So instead of that, your class or the high level class which you are implementing based on the expense consolidation need to use the abstraction. So here we are using the employee expense abstraction. You can pass any employee expense subtype, that developer expense, manager expense or intern expense. But if we have really directly given the manager expense or any class which implements this employee expense, then this is no longer flexible code. So this is same for employee compensation consolidation as well. So here in this case, we have passed in the full-time employee expense rather than passing in like developer expense or manager expense. We have passed in the abstraction because the full-time expense is an interface which is an abstraction. So by this way, we have adhered to the dependency inversion. So what is the advantage of using dependency inversion? Dependency inversion provides a decoupling between different modules. That is, like, the high level component is not dependent on the implementing class, rather than it just depends on the abstraction, so that you can pass any type which is a subtype of that particular abstract or interface. And here obviously there is a code reusability. Just think through, if that consolidation class only takes manager expense, then you need to create another class which uses developer expense, and then you need to create another class which takes the intern expense. So this increases the code reusability, and the high modules becomes more flexible. Here in this case, the I module is the department salary consolidation or department compensation consolidation. Here this is directly utilizing the full-time employee expense interface, and here it directly uses employee expense. Thanks for watching this video. For more technical videos, subscribe to this channel. If you feel this content is really helpful, share it with your friends.